Bună dimineața! Este un moment mai special pentru noi. Faptul că una din cele mai bune serii ale noastre de la programul de energetică industrială a ajuns la acest moment final al examenului de licență. Și e un lucru deosebit. Suntem aici colegii din cadrul departamentului nostru. Aș vrea să salut pe domnul Cosmin Bucur, pe domnul Prodan Gabriel, doamna Izet Kunsel și pe domnul Liviu Mateescu. Împreună vom fi astăzi, împreună cu studenții noștri, să-i vedem strălucind cu realizările lor de la acest examen de licență. Și pentru a face acest moment deosebit, am invitat și mulțumim din suflet domnului profesor Enricco Sciubba, care a acceptat invitația ca în deschiderea acestui eveniment să adreseze studenților noștri și întregii comunități academice de la universitatea noastră un discurs legat de acest moment. Și din această perspectivă o să începem să vorbim în limba engleză, because we are not that Latin to speak Italian as the second mother tongue. So allow me to introduce Professor Enricco. Professor Sciubba is the Doctor Honoris Causa of the Ovidius University. Let me start with this. He accepted this honor in 2008. Professor Sciubba is a Roman by grew up in Rome. He was educated in Rome, and then he went to the US. He got, let's say, research field and research activities in US. He worked in the US, and then he came back to Rome, and he accomplished an academic career at the university. Today, Professor Sciubba is world recognized in the field of thermodynamics, applied thermodynamics, particularly his achievements in the field of, let's say, the development of new tools regarding the analysis, model optimization of thermal energy systems. They are recognized and used all around the world. In many other research groups have followed his activities. Sciubba, as I was saying, he was one of the pioneers in the late 70s artificial intelligence tools and let's say software programming connected to research activities in the field of applied thermodynamics. And for many years, this was an activity which then at a certain point became very being upscaled, some software developments that are now commercial, used by experts in the field. Today, now, he is basically using his ideas from the 70s with the reboost of artificial intelligence and digitalization in all kinds of engineering. So, once again, thank you for accepting at this very early day of your holiday, actually, to be together with us and with our students. And I am passing now you the microphone. Thank you. You have to unmute the microphone.
I did unmute. Is it okay? Do you hear me?
No, it's okay. Yes.
Okay. Mulțumesc, Eden, and bună dimineața to everybody. I will put the slides with the text of my presentation, my speech, my address. I will share my screen. And the reason is that my English, first, I'm speaking fast, and second, my English has an accent, and some of you may be not able to understand my Italian accent. So let me share my screen first, and then I will start talking, okay? You hear me?
Yeah.
Okay. So let's see if I can do this. Share screen. From beginning. No, I can't do this. First, share screen. Share the screen.
But then you have to select the window in which you have opened the document.
Yeah. Do you hear? Do you see it now? Do you see the slides?
No, not yet. No.
And then I don't know how to do it.
So if you want, we can help you.
Well, do you have my slides?
Sharing from here.
Okay, but you don't have the slides.
I mean your speech. We don't have the slides. Yeah, we have the speech.
Just tell me how to do it. I'm clicking here. I have my PowerPoint on the screen.
But your PowerPoint, you have to put it as a full screen.
I put it as a full screen, and then it hides my my webinar.
Doesn't matter, because we should have seen it.
Okay. So if I go share my screen,
and then you have to...
Okay. I got it. Share. You see it now?
Yes, now it's okay. Yeah.
Okay. Okay. Well, let me brag about my Romanian. Domnilor și domnilor, colegii de la Facultatea de Ingegneria, dragi studenți absolvenți, acum probabil vei credeți, ai mei, voi continua discursul de absolvire în frumosa limba romena, cea mai apropiată de latina antică despre care se vorbește în prezent. Dar, din păcate, limba romena se termină aici. Și voi trece la engleza mai comune, dar mai frigidă. The question that many of you will ask yourself is, why did your school call a guy from Roma to deliver this graduation speech? Well, one of the reasons is the name of your university. I'm not the first Roman to visit Constanza. Exactly 2012 years ago, in the eighth year of the modern era, an Italian poet, Publius Ovidius, was exiled to Scythia. The name of the region was Scythia at that time, in the city of Tomi. The name of Constanza was Tomi at that time. And he was exiled because there were rumors that he had an affair with either the wife or the daughter of the emperor. However, he stayed long in Constanza, resided long. Actually, he died there, and he wrote some of his best poems in Constanza. So that is the connection. After 2,000 years, I was supposed to be there physically today. Unfortunately, this COVID situation doesn't allow me to be there. So I reappear virtually. And I hope to be there soon to lecture. Though, of course, Ovidius' poems are much better than my lectures, and for sure less boring. So this is the cultural connection. Is there another link between the degree you are receiving today, which is an important day of your life, and ancient Roma? But let's take a look from the very beginning. Engineering, the Webster Dictionary definition: application of science and mathematics by which the properties of matter and the sources of energy in nature are made useful to people. B, the second activity is the design and manufacture of a complex products. But your degree is in energy engineering, which is defined by Webster as a broad field of engineering dealing with energy efficiency, energy service, facility management, plant engineering, environmental compliance, sustainable energy and renewable energy technologies, a very broad field. I don't like really the word sustainability, but Webster doesn't know it, so let's skip it for a second. When I come to Costanza, we'll talk about it. Now, these have been 4 years or more of your life. You get this degree in Energetica Industriale. What does it mean? It means that you have become, through these years of toiling, applied scientists, Webster Dictionary, designers, Webster Dictionary, managers, Webster Dictionary. Let me tell you, there is no other profession that gives you these capabilities or requires you these capabilities. You have been taught to use science, applied scientists. You are not philosophers of science. You are applied scientists, which means that you have to look at a physical problem, understand it, being able to describe it, being able to represent it in mathematical symbols, and to solve the mathematical equations to find the solution. Okay, you will see if you have a brother or a sister or a mother or a father, physicists or mathematicians, they will say, hey, we can do that too. Yeah, okay, but we are also designers. We can create a device to implement a solution that we have only on paper. We can design its details and assemble it and build it. Okay, some clever craftsman will say, look, I can do the same thing. Sure, but he can do it only once and only in his single specific field. In your life, you will design probably hundreds of devices of different, belonging to different fields: heat exchangers, turbines, compressors, engines, and so on and so on. And finally, and this is very important, you will be managers. You have been taught to be managers. You will be able to organize and overlook the construction, operation, and decommissioning of whatever you design. And look, if you take a look at your, I don't know exactly the Romanian situation, but if you take a look at the background of most managers in industry and in public agencies which deal with industrial topics, you will find that many of them are not economists, they're engineers. And there is a very clear reason for this, because for an economist to understand what a combined plant is an impossible task. And I don't want to offend economists. But for an engineer to understand how to read a budget is a task that he completes in 1.5 days. So we are really complete in our education. Again, you know, on the field technicians can organize a small part of the managing of the plant, but it took them 25 years to do this. And they do it out of habit, you do it out of deduction, because you know what to do, when to do, why you're doing it, and how to do it, because you have been taught to this. You don't do it by just trial and error. Well, it has worked before, let's do it again and try and see what happens. No, you know the background about this, okay? Now, why the Romans? Why do we have to call a Roman to talk about Romans at your graduation speech? Well, ancient Romans were known for their remarkable engineering capability. Okay, the most known stuff we Romans, let me say that, we Romans, my ancestors, built were roads, of course, bridges and tunnels, aqueducts, and machinery. The interesting thing is that Roman engineers were not philosophers of science. They very often just improved upon older ideas and inventions introduced, but while copying these inventions, a great number of innovations. They developed also materials and techniques, so they were very practical engineers. You don't find a Roman physicist or a Roman mathematician famous whose name went through history. They were really engineers. Let's take aqueducts, for instance. Before the Roman times, stone and wood and sometimes lead water channels had already existed in the Middle East for centuries. But Roma built the first aqueduct, the Aqua Appia, in 312 before Christ. But they introduced a lot of innovation in this design. For one thing, they led the water in an almost straight line from the source to the city. They excavated tunnels and pipelines and so on and so on. And they brought water to the city, which meant safety, cleanliness, and high standards of life for that time. Okay, the houses of the wealthy Romans had pools. Middle class didn't exist, and the proletarians, which was called the vulgus, they had fountains where to wash themselves, which avoided sicknesses due to hygienic lackness. They also used the aqueducts to drive water mills for grain and for working stones. Sometimes in physics books and engineering books, you find sentences like the Romans did not know Bernoulli's principle because they led the water, to lead the water, they had to build these arches like this, that go to a slight descent from the mountains to the city. Well, that's not true. They knew Bernoulli principle because they didn't know Bernoulli, of course. They knew the principle that water goes up as much as it's come down almost in a closed pipe, and they used it in fountains and other devices, but they had technological problems. They could not able to build closed pipes, sealed pipes, metallic pipes, which were longer than a few inches or centimeters, because they didn't have the technology. They didn't know how to weld. They knew brazing, but they didn't weld. And also, the water was, of course, was clogging the pipes by the debris that it was carrying and scaling, because the water around Rome has a high content of calcium and magnesium. And so you need a lot of maintenance, frequent cleaning interventions. So they couldn't use watertight tubes, and they had to use channels. Now, the aqueducts required an immense amount of work. They had to build arcades, to build tunnels, to build viaducts. For instance, this Aqua Marcia aqueduct, built in the 2nd century before Christ, ran underground in a tunnel for about 91 kilometers out of 100, okay? And then only 10 kilometers above ground to get to the city. This is a map of the ancient aqueduct, of which we still see here, we still see the remnants in modern, this is a countryside, like I think it's 5 kilometers from the center of Rome. So this thing was coming in. And this is an artistic view of how this was built. They use machines. This was also a perfection of an existing machine. Roads. You want to talk about the roads? Roman roads are everywhere through Europe. In the cumulative time it took them to go from republic to empire and then to be annihilated, Romans built over 120,000 kilometers of street roads. The Italian word strada for road comes from la strata, which means plastered with stone. They used, of course, the roads for commercial, for trade, but also for military use, because their armies could be moved from one country to the other very quickly. This is a piece of Via Appia, just a few kilometers outside of Rome. People used to go jogging there. This was built over 60 years in the 3rd century before Christ. Okay? And it's still, well, it's forbidden, of course. It's traffic is forbidden here, but you can ride a bicycle on this thing. 2,300-old road. Bridges. The bridges were a stronghold in the Roman engineering. They invented, well, they didn't invent, but perfected this cornerstone. Actually, the word cornerstone comes from this heavy stone which was placed here, and with its weight discharged the forces onto the pillars. Now, they of course didn't know modern static, but they knew how to use this fact, this phenomenon. This bridge is in France, northeast France, 1st century before Christ. And this one is a famous Ponte Milvio in Rome. Ponte Milvio is the Italian name. It was built about 200 BC. It was rebuilt several times, but still the pillars and part of the arches are, and these towers are Roman. Its original name was Pons Molvius. Molvius was the Roman praetor, or questor, I think, who signed the document which allowed the bridge to be built. This bridge is 2,200 years old and still standing, which you cannot say for many modern bridges built by modern Romans. Tunnels. Tunnels were another characteristic of Roman engineers. Very difficult construction with the methods they used then. The tunnel was one thing, for instance, that if you can think of it, you start digging a tunnel, but if you're not careful, you don't know where you're coming out. So you have to be careful to follow a certain line. And they had methods, which are explained in the slides. I don't want to go, it's too technical, to follow a certain line. And they even invented the counter-excavation method, for which is used today, still used today. One crew starts from one end, the other crew starts from the other end of the mountain, and they meet at the center. And of course, you need very careful planning to to make the meeting point correct. And they had a lot of methods, very simple methods, very ingenious, to control this building, and also to check the excavation, to bring ventilation to the tunnel, and so on and so on. Their tunnels are still standing. This is a tunnel near Rome, on the Via Flaminia. And as you see, this is still the entering arch with the Roman wall. And this is a view that shows you that the tunnel is not straight, okay? And they started from one end and from this end, and they met at the center. So they knew somehow. And you also see that the stone is granite, so not easy to dig. But they have many ways of cracking it. And the most common was they use fire to heat up the stone, and then suddenly they cooled it, they quenched it with water, and the stone cracked. And then they took away the crushed stones. Romans are most famous, Roman engineers, for inventing concrete. They actually invented concrete, which they called opus cementitium. Now, the procedure is the same as the one we use today, only the material was different. They had a lot of volcanic ashes, and they used that as a filler. Now, astonishingly, modern studies have shown that the Romans' concrete was better than today's Portland cement, standard Portland cement. As a matter of fact, we have ancient Roman harbors whose walls, or part of the walls, have been exposed to the sea for 2,000 years, and they still stand. After 50 years, Portland cement begins to erode. And the reason is that they had a different filler, the Romans. They used terracotta, and crushed terracotta, of course, and volcanic ashes. And this binds very well. And as a matter of fact, in Rome, most of the buildings are still standing, made with this concrete. Mills and water devices. Roman engineers knew the water mills which were used in ancient Persia. The Persians were the inventors practically of the water mills and of the irrigation channels. But the Romans perfected technology and installed a large number of horizontal and vertical water wheels. We're talking about 300 something, 200 something years before Christ. And they used it both for milling purposes and for what we would say today industrial purposes, sawing wood, crushing stones, and metal ores. They also used hydraulically powered hammers to crush stones. The stones were mined underground, and they had Romans engineers devised very clever ways of mining. One was the so-called flushing way. They built a large water tank on a hill and then filled it, and then released the water, channeling on an open pit where they wanted to dig. The water would just flush the earth, the superficial earth away, and then they would start digging. Another mining was to break the rocks with fire, like they did in the tunnel. They heat it up and then quenching with water. Weapon technology. I'm talking about weapons, not because I like weapons, but because the technology in those years was directed towards weaponry. Again, the Romans copied the Greek ballistra, which is this. Ballistra is, you know what it is. It's like a bow, okay? A bow which you charge and then release because it has an elastic, usually made of a rope or a leather, or a leather rope. And that was already used by the Greeks. The Romans perfected it in many typically Roman ways. This is a reconstruction of a Roman ballista. This thing is built in such a way that it can be assembled on the field, because the soldiers didn't have to carry the whole thing. this was dismantled, and then each part was carried separately, making its transportation more easy. And the Romans also added some parts of steel, making it more resistant. More resistant means that it had that it could shoot like 25% farther than the Greek ballista, which in those wars was important. But the most important invention of the Romans was the onagger, and that's again very interesting consideration. This is an ancient catapulta, what's called. Okay, the catapulta works by pulling it down and then releasing, and then it throws something against the wall of the city you want to siege. The Romans said that this sling, which improves much both the range and the strength of this weapon, and also they typically built it in such a way that it could be assembled on the field. You see there is wood, but also metal parts, and they added little supports that would avoid the what is called the shoot back, the backfiring, so to say, of this device, which could be dangerous for soldiers. So these things were ensuring that the onagger would stand still and not move back when shooting. And again, this sling improves much the range of the weapon. Now, they didn't know, of course, dynamics in the sense we know today. They couldn't calculate, for instance, the trajectory of the stone they were launching. It's amazing that they just built this out of intuition. Naval architecture. This is an extraordinary example of the advancement of the capabilities of the Roman engineers. Romans were not able to build ships because they didn't care about naval warfare. They had invaded all Italy with their infantry. And when they started the Carthago War, Carthago was a city in Tunisia, in today's Tunisia. They were at first defeated by the strong naval army of the Tunisians, of the Carthaginians. Now they captured about, in 2060 something, they captured, or so the history goes, a large enemy warship. What they did, they reverse engineered it and copied it. And then in the years, they perfected it. What happened? In the second and third Carthago War, they defeated the Carthaginians with the new ships. And you can see the evolution of the ships. This is a ship in what's called the Pentaconter, 220 before Christ. Very similar to the Carthaginians ships, to the Tunisian ships. After 2 years, you see some subtle changes here. There is a place where the archer or a group of archers would stand and would shoot on the enemy ships. The rostrum is deeper in the water, and it's made of bronze. It's a deadly weapon. They used to launch the ship against the enemy ships and just sink them by ramming. After 150, 170 years, the ships have become more sophisticated, and they even had layers of copper around the water line to strengthen, to increase the resistance to being rammed. And the most interesting thing is that Romans used to fight at sea the way, or they tried to fight at sea the same way they fight on land. They invented the ramming bridge, which was a bridge that have you seen the movies, the pirates and stuff like that? Well, the Romans invented that. They just launched these bridges on the enemy ship and then sent the infantry, launched an attack on the ship. So there was a clever way of using their strength, the infantry. Also, naval architecture implies the building of harbors. This is a reconstruction of the Portus Traianus, Trajan harbor in Ostia, which is the 15 kilometers west of Rome. And as you see, the harbor is designed in a way that modern engineers couldn't perfect, really. This is a safe space. Any kind of wind doesn't disturb the ships. There is a Darsena to put the ships for repair and to build the new ships and launch them. And it is connected to the river Tiber and to land. So it's an interesting planning in this construction. It was also used for commercial purposes, and of course there was an imperial palace here. This was built in the 2nd century before Christ. You look at this and don't tell me that you wouldn't think that this was built in more recent time, maybe today. Okay, now you will be asking, if you are still awake, why is this guy talking about ancient Romans? Well, first of all, because I am Roman and I like to brag about my people's past achievements, especially because if you look at your TV news, you will see that I don't have much to brag about my present Romans. So let me go back to the past and our glorious past. Even the football team in Roma is doing poorly. So the second reason, and seriously, is because I think that this excursus that I gave you very well describes a few lessons that you might find useful for your career. First of all, diligence. Engineering is a hard task, a complicated task too. You cannot be superficial when you perform an engineering task. You must you keep concentration. You have to keep your concentration on your work. Don't be led astray by secondary considerations, always keeping in mind your goal, which is your originally stated design task. Second, multidisciplinarity. Our profession is inherently multidisciplinary. There is no time anymore for knowing everything scientists, okay, like Leonardo or Brunelleschi or Michelangelo or whatever. There is no time for them. Experts can be experts only in a very small, relatively small field, except for those who go on TV and talk about everything. But in engineering, you don't need these guys. You have to stay away from experts of everything. You have to consult with your peer engineers, with your managers, with economists, with physicists, with material scientists, with environmental experts, with sociologists at times, with historians. Always with an open mind attitude. That means you listen to them to help you make the correct decision. Keep in mind that several brains, when they work in concert in good faith, always achieve better results, obviously, than a single guy doing everything. Okay. Another thing is multidisciplinarity means that you have to include what we call unskilled workers. Okay. This is not Bish attitude on our side. The guy who assembles the machinery you have designed, most likely, knows the device much better than you. And so he knows how to assemble better to service it later or to make modifications at a later stage. So listen to them too. It's invaluable, the advice that you can get from people that you usually have a tendency to look down to. Okay, don't do that. Use their experience. Work planning. Engineers are known for being well-organized people. Okay, there are many jokes about engineers being organized. Well, these are true jokes. Our job is essentially an organization work. Plan carefully, organize in advance, make small changes to the planning when and if necessary. Don't become led astray by customers who insist that they are in a hurry, funding agencies who want reports ahead of time, your bosses who wants to cash on your design early, any organization. Don't take shortcuts. To do this, you have to be ready to sit down and discuss and defend your choices, because your choices are made intelligently with your engineeringly educated intellect. And we know out of experience that managers always or often are motivated by different considerations. Direct and indirect creativity. One of the critiques which is always made against engineers is that physicists are creative, historians are creative, actors are creative, but we are not creative. Well, that's not true. First of all, design is a creative activity. Second, you shouldn't be afraid to copy. Look at the Romans. They took a ship, copied it, and then perfected it. Do the same. If a device or a process works well, why don't you copy it? Reproduce it as it stands. You will be surprised how often by doing this, you will find that you can improve it. But first you have to understand how it is operating. You have to get insight. So you have to learn to copy. Don't be afraid to copy. Capitalize on your own mistakes. Everybody makes mistakes. Okay? Nobody's perfect. You know it when you write your first computer code. Okay? It never works the first time around. Go back, study the process you have implemented, try to find the mistake, what went wrong, then go back, study a little more, look at your manuals, ask experts, and then go back and correct. And often you have to repeat this several times. Now, this is my, speech to your 21 graduating engineers. I see that there are only 7 women. I don't have the pictures of these girls in front of me, but I know that Romanian women are beautiful. Now, there is a say in Italy that a beautiful girl cannot be intelligent. I would say exhort Romanian women to convince yourself that you can be beautiful and intelligent and to compete with this engineering man's only work. So I hope next year I will be invited again to a graduating speech, and I will have like 22 graduates, 11 boys and 11 girls, which is the way it should be. I also see that the majority of you have high marks, which is good. It's a good promise. Of course, the grades in the school are not a promise, exactly a reflection of your future life, but it's better to get a good grade than a bad grade, of course. I discussed your graduation with Professor Mahmoud before the speech, and I'm told that very few of you will go for a PhD. Okay, I know that this is because your job situation is good. You land a job within a year, either in your country or abroad. But I would exhort some of you to consider seriously going through the PhD career. We need researchers. It's good for the country and it's good for the community. And engineering academic life is not bad. Okay, you get to know people, travel around the world, go to conferences, and so on and so on. Final thought: to your families. I'm sure you don't have to say that or acknowledge that or that, but you owe maybe 1/4 of your success to us professors, 1/4 to your study, more or less, and the rest 50% is your family. They supported you. They often encourage you to take this career, to undertake this career. So when you get drunk tonight and celebrate, after you get sober, find another day to celebrate with your family, because they deserve it. Okay. Let me say that because my last son, my youngest son, just graduated 2 weeks ago in physics, unfortunately. And in physics, and of course, being a physicist, he claims that I don't understand entropy. So I have an enemy in my own family. But the fact that he graduated as a father, I'm particularly happy because I will stop paying alimonies to his mother. So that may apply to your families too. So they will be happy as well. Seriously, best of luck to all of you. I hope to see you in the future, maybe when I come to Costanza, maybe in Italy, you never know. Okay? And our sincere applause from your colleague engineer. Thank you very much.
Thank you very much, Professor Enricco Sciubba. It was a very, very inspiring work, making an arch over the centuries and defining the spirit of Latinity, which means to be open to everything that you can learn from all around the world, and then to improve it. So it's a fantastic message that would be excellent for our graduates. So if there are some questions from our graduates, very shortly for Professor Sciubba, because actually he is also planning, we don't know yet how to these aspects of COVID and so on will happen, but we are planning a short summer school during this summer here in Constanza. We hope we shall have this opportunity, but up to then, if there are some questions, please, you have the floor. E cineva care dorește să-l întrebe ceva în mod special pe domnul profesor? Andreea, poate totuși ai putea tu să spui două cuvinte din partea colegilor. Ce părere ai? Andreea Deștepău.
Bună ziua and good morning for Professor Sciubba. I'd like to say that I'm honored to be here with you, and this is so important for us because dar am emoții. I don't know what to say. And
say it in Romanian. Professor Mahmud will translate.
În primul rând am dorit să vă mulțumim că sunteți aici alături de noi.
So you understood this because she wants to thank you because you accepted to be here with them.
Este o foarte mare onoare pentru noi că sunteți prezent.
It is a very great honor for us that you accepted and gave this.
Mai ales că este o zi atât de importantă pentru noi.
Mostly because it is such an important day that you mark all of us.
Vă mulțumim frumos și mulțumim tot binele și dumneavoastră.
So thank you for all the good thoughts.
Okay, thank you, Andrea. And I know it's an important day, and that's why I took almost 2 hours of my beach time. I'm supposed to go to the beach today after this graduation speech. So joke aside, it's a great day for you, I know. And remember, this changes your life. This is a milestone in your life. It changes your life. In 10 years, 20 years, 30 years, you will go back to this day as a milestone. Thank you, however. I'm happy you liked it, my speech.